Hey everyone, in this video I'm going to show you how to set up and test a hypothesis for comparing two populations with one categorical variable. So the data set we have here is wondering about, do smokers tend to have more girl or boy babies compared to non-smokers? So let's look at a table of our data, the smokers and the non-smokers. So in this data set, there were 3,602 couples who were non-smokers and 565 couples who were smokers. In the non-smoking couples, they had about 55% of their babies were boys and 45% were girls. For the smokers, it was sort of reversed. 45% were boys and 55% were girls. And the question here is, and let's focus on girls for the moment, were smokers more likely to have girls than non-smokers? Now, the null hypothesis is that the percentages in the populations should be the same. And we can model that by taking the non-smokers and smokers data and combining them. And the way we do that is we go to data and then arrange, and we're going to stack these two columns on top of each other. So I compute that. And var3 here, that's telling us which column things came from. And var4 is telling us whether it was a girl or a boy. So var4 is our model, in particular our null model. So now what we're going to do is replicate our study. We're going to do many samples of 3,602 non-smokers, many samples of 565 smokers, compute the percentage of each sample that was girls, and then look at the difference. So we're going to go to data, sample. We're going to sample from our model. Let's do the non-smokers first. So 3,602 non-smokers. Let's do 10,000. We're going to sample with replacement. And we're going to build this. We're going to do the sum of the sample from the model. And this is equal to girl. So this is going to be, let's specify non-smoker girls. And you could either count the number of girls, but it's going to be better if we look at the percentage number of girls. So we can take our sum, and we're going to divide by 3,602. So just take a moment, or two, or three. Okay, so this is showing us that in our first simulated sample, about 46% of the babies were girls. And in the next one, 46.9% were girls, and so on. So these are simulated non-smoker samples. Now we're going to do the same thing for smokers. So we go to data, we're going to sample from our model, and now our sample size is going to be 565 to match the smokers. We're going to do 10,000 with replacement, and we're going to add up all of the girls in the model, and instead of dividing by 3,602, we're going to divide by 565 because that's our sample size. And we're going to call this smokers girls. Give this a moment. Okay. So now we have 10,000 simulated samples of non-smoker couples. We looked at the percent of each sample that was a girl. We did the same for the smokers. And these were all coming from our null model that said that there was no difference between the smokers and the non-smokers. Now the statistic that we computed, it was a compound statistic. We looked at either smokers minus non-smokers or non-smokers minus smokers. You could do it either way. Let's look at non-smokers minus smokers. So what we want to do is we want to compute an expression. I'm going to build this up. So let's do non-smoker girls minus smoker girls. The percent of girls out of the non-smoker couples minus the percent of girls in the smoker couples. You can compute that. Okay, so now we have a sampling distribution. This is a sampling distribution of differences between percentages from the non-smokers minus smokers. And what we need to do is we need to look at our observed statistic. So we're doing girls, non-smokers minus smokers. So we've got 45.169% and 54.867%. And I'm going to open up my calculator. So we had 0.4516935 minus 0.54867257. So this is our observed statistic. In the two samples, the non-smokers minus smokers, the observed statistic was negative 0.09697907. So this is what we'll look for in our sampling distribution. So now let's make a sampling distribution, or let's visualize it. We'll make a dot plot of the differences. Now I'm going to make percent here. Okay, here's our dot plot. I'll make this big. And now remember, the number we're looking for is negative 0.09697907. So I'm going to take this handle, 7907, negative. And what you might notice is this special number, negative 0.09697907, it doesn't even appear down here. The smallest number we have, this is a difference of negative 0.0867775783. The observed difference isn't even in the sampling distribution. So this means there's a p-value of 0, which means if our null hypothesis is true, and there's no difference between smokers and non-smokers, then there's a 0% chance of getting our observed statistic. So our observed statistic is strong evidence against the null hypothesis. And we can conclude that there is a difference between the percent of girls had by smokers and non-smokers.